Hi, and welcome to this video on laws of proportion and percent composition. We're going to take a look today at how formulas of compounds actually, how we can compare them and what we know about them, and then determine the percent composition of different elements inside of a compound. So grab your notebook and something to write with, and let's get started. Before we go too far, I wanted to just share a joke with you. Two men walk into a bar. The first orders some H2O. The second one says, "Sounds good, I'll have some H2O too." Unfortunately, the second man dies. So if you don't know why that's the case, well, hang on, because we're going to get there. So the first thing we're going to do today is we're going to take a look at the laws of proportion. And so we know that there's a couple different laws of proportion, and the first one is that we have the law of definite proportion. So definite meaning that it's absolutely going to have this specific proportion. And so it's a specific compound has the same proportion of elements. So no matter what, if we have a particular compound, it's always going to have the same elements in the same proportions. So I have a couple examples for you here. We see that water is H2O, and water is always H2O. We don't ever have water, or at least pure water, with anything else other than H2O. And we know that methane is CH4, so methane gas, and it's always CH4. So whenever you see CH4, it's always methane. If you had C2H8, it wouldn't be methane, it would be something different. And sodium chloride is another example. So we know that whenever we have sodium and chlorine together, they form sodium chloride, and that is exactly, it's a 1-to-1 ratio. And so each one of these compounds has a very specific or definite proportion. The other law that we have is the law of multiple proportions. And so the law of multiple proportions is where if we have the same elements in different proportions, they are different compounds. So we can have the same exact elements, but if we have different numbers of them, then it's going to be a different compound. And so there's a couple examples for these. This actually comes back to that joke at the very beginning. H2O is water, but H2O2 is hydrogen peroxide. Water we can readily drink, but hydrogen peroxide is, well, deadly to us. And so having that extra O on H2O2 actually changes the entire compound to be something different. And so those proportions are very specific. Same elements, different proportions of those elements. And so we have two O's in the one versus only one in the other. Another example that we tend to see is copper 1 chloride and copper 2 chloride. And so with these ones, we have copper and chlorine that are put together, but we know that they have to be different because, well, one has copper 1 and one has copper 2. And so when we see that we have different numbers of chlorines in them. And actually, when we look at these, we also see that they're different colors. So the one on the left is copper 1, and the one on the right is copper 2. And so they're very different colors, and both of them are copper chloride, but they have different proportions. So this one's going to have 2 chlorines in it versus only 1 chlorine here. And so knowing those formulas is very important. We really don't touch much more on these, but I just want to really impress upon you that knowing the actual formulas is very important. We're going to learn soon how we actually can determine those experimentally, how our formulas are made. All right, so percent composition. So once we know the formula of our compounds, we can actually start to do some analysis with them. And if we don't know them, we can actually do some analysis to find them. And so percent composition is where we have a percent by mass of elements in a compound. And we can determine this. And there's actually, I do 3 problem-solving steps for this. So I'm going to show you each one, and then we'll do a sample problem. So the first thing that I have to do is calculate molar mass. And like I told you guys in class and in the last video, we really work with molar mass the remainder of this year. It's just a constant thing that we're always calculating and using in chemistry. After we've calculated molar mass, we're going to calculate the mass of a particular element in a compound, or maybe all of the elements in the compound. And so we want to know the specific mass of those elements in the compound. And then finally, what we do is we determine our percent composition. And so we have an equation to do this. And so it is going to be percent composition is going to be the mass of our element, okay, and it's the total mass of the element in the compound divided by the mass of the compound, which is our molar mass. And then we're going to multiply that by 100. So that takes us from a decimal to a percent. And so let's do an example of this. Let me get on to the next slide here. Okay, so here's an example for us. We have glucose, so C6H12O6, and what is the percent composition of each element in glucose? And so what I want to do is I want to take those steps that we were just talking about. So for carbon, okay, I'm going to do carbon first. I know that the percent composition for carbon, so this is going to be the percent for carbon, is going to be equal to the mass of carbon. So I have 6 carbon atoms in a molecule of glucose. So 6 times my mass of carbon is going to be what goes on the top. And so I'm going to do 6 times my mass of carbon, which is 12 grams on the periodic table, okay, divided by the molar mass. And if you remember, the molar mass for this compound was 180 grams per mole. Okay, and if you don't remember how to do that, go back and watch the video on molar mass again, or look back in your notes and see how you did that. So we're going to take the total mass for carbon on the top, and then we want to divide that by the molar mass of our compound, which is 180 grams. Okay, so 180 grams. And so when I do this, that 6 times 12 gives me 72 grams for carbon in that molecule, divided by the 180 grams. Now, when we're doing this, the grams are going to cancel, and then I'm also going to multiply this by 100. Okay, so when I do that, I end up with 72 divided by 180. I do that first, I hit equals, and then I multiply by 100, and I get that this is going to be 40%. So 40% of glucose is actually comprised of carbon. And then I can do the same thing with the other two. And so I'll do these a little bit faster. So the percent for hydrogen, I know that I have 12 hydrogens. Each hydrogen is 1 gram per mole. And so that's going to give me a total of 12 grams divided by 180 grams for the molar mass, times 100, and when I calculate that one out, I get 6.7%. And then finally, for the percent that comes from oxygen, we have 6 oxygens. Each one of those oxygens on the periodic table has a mass of 16 grams. And so when I take 6 times 16, I get 96 grams. So I'm doing a little bit of that in my head, or I've already done some of that on the paper, divided by 180 grams. Again, grams are going to cancel, so we don't end up with units at the end of this. I multiply that by 100, and I should get 53.3%. Now, theoretically, whatever this plus this added up to should be this one here. Sometimes I'll ask you for just one of those elements in the compound. Sometimes maybe you'll be asked to do all of them, but that's how you actually determine percent composition of any given element in a compound. I hope that's helpful, and we'll see you soon.